Dear students, Standard 10, Unit 1, Lecture 6. Here we learn about the fundamental theorem of arithmetic. It says that every composite number can be expressed, or you can say factorized, as a product of primes, and this factorization is unique apart from the order in which the prime factor occur. To understand this theorem, let us learn some examples. Let us take exercise 1.2 question 1, and in the question 1 there are 3 sums we are given to factorize, and one of them, the first one, is 140. So how shall we express it, and what is said in the instruction? Express each number as a product of prime factor. So let us make prime factors of 140. As 140 is even number, it can be divided with factor 2. So let's divide it with 2. When we divide 140 with 2, we get 70. 70 is also an even number, so it can also be divided with 2. So we got 35. Now 35 is not divided with 2. Its factors are 5 7s are 35. So let us divide it with 5. So we got, as a factorization, 5 7s are 35. Now 7 is divided only with 7. Now this expression can be expressed in another way, and it is called factorization tree. And to express the factors of 140 in prime factors tree, first of all we will write 2 factors of 140. They are 2 and 70 under the box of 140. And now we will write factors of 70 with prime factor 2. So factors of 70 with prime factors 2 are 2 35s are 70. So we will write 2 and 35. Now factors of 35 are 5 and 7. So we'll write 5 and 7 under the boxes of 35. Now factors of 7 are 7 1s are 7. So we'll write 7 1s are 7 under the boxes of 7. So here the same thing which I have expressed before, the same thing I have expressed in the form of prime factors tree. Now we'll write the answer. And the factors of 140, the prime factors, are 2 square into 5 into 7. I have written 2 square because 2 comes twice in the total factorization. Let's see the number 2. So for the sum number 2, we are given one integer 156, and factors of 156 with 2 are 2 into 78, and then factors of 78 are 2 into 39, then factors of 39 are 3 13s are 39, and factors of 13 are 13 into 1. So total factors are 2 square into 3 into 13, and answer of the next 3 sums are here I have written, and you will solve and find whether the answers are right or wrong. Okay, you will solve question 3 4 5 as I have solved 1 and 2. Okay, so that's your practice work. Let's learn the next topic. Find H.C.F and L.C.M with the help of prime factorization method. To understand this thing, let's take one example. Let's take 2 integers. One is 540 and the second one is 504. So we'll find H.C.F and L.C.M with the help of prime factors. So first of all we'll make prime factors of 540. So prime factor of 540 is 2 square into 3 into 5. And now let's take prime factors of 504. And prime factors of 504 are 2 is thrice, therefore 2 cube, into 3 is twice, therefore 3 square, into 7, 2 cube, 3 square, into 7. Now if you want to find out HCF of both of these integers, highest common factor of both of these integers, we'll see which prime factor is common in the prime factorization. Here we see 2 is the common factor in both of these integers factors, and same way the 3 is also common. So we write 2 and 3 as a common factors. Highest common factor, it means the factors which are common for maximum time. Now what about their power? Now in 540 2 has power 2, and in 504 2 has power 3. So which is the highest power? For 2, 3 is the highest power and the smallest power is 2. So 2 has power 2 in 540 and power 3 in 504. So we'll write the lowest power, that is 2. We'll do same thing with 3. In 540 3 has power 3, and in 504 3 has power 2. Now which power is the lowest power? So 3 has the lowest power 2. So that will write in HCF. Will write 2 on 3. Understand? So when we write HCF, we will write common factor with lowest power. Okay, and now we'll write the value of HCF, and value of HCF of both of these number is 36. Let's write LCM. To write LCM, we'll write all factors, common and non-common, all factors we will write with their highest power. And therefore for answer, to get the answer of LCM, I have written all the factors. The common factors 2 and 3 I have written, with them I have written non-common factors 5 and 7. But this time I will write the highest powers of 2 and 3. Highest power of 2 is 3, and the highest power of 3 is also 3. So I will write power 3 over 2 and power 3 again on 3. So by doing this, the value of the LCM will be 7560. That is the value of LCM. Understood? Now one more thing I want to explain here, taking these values of integers and their HCF and LCM. First of all, let's take multiplication, product of the given two integers. Product of given integers 540 and 504, that is 2160. 2,72,160. Now get the product of LCF and HCF, and the product of HCF and LCM 36 into 7,560, that here we got answer 2,72,160. So product of integers and products of LCF, LCM and HCF are equal. So we can write a formula here. Product of HCF and LCM equals to product of integer. Understand? So here this result we got, and we use this result to prove the given result as well as to find LCM when we are asked to find out HCF with the method of Euclid's, and also asked to find out LCM. We will use the next formula that I am going to explain here. If we say for 540 integer A and for 504 integer B, we can present this result HCF of AB into LCM of AB is equal to A into B. And if we bring H.C.F in the division of A cross B, we can present the formula as LCM of AB equals to product of AB divided with H.C.F of AB. We can use this formula in some of the next questions. Using this knowledge, we can solve question 2 of exercise 1.2. There are 3 sums given. For the first sum, we are given 2 integers 26 and 91 to find out HCF and LCM with the help of prime factorization method. So first of all, we'll make prime factors of 26 and 91. And the prime factors of 26 are 2 into 13 and prime factors of 91 are 7 into 13. Now to write HCF, we'll write common factor 13, and to write LCM of 26 and 91, we will write common factors as well as non-common factors 2 and 7 too. And so we got LCM as 182. Okay, now we are asked to find out, to prove that, to check out that product of integers is equal to the product of HCF and LCM. So let's check it out. And product of integer is 26 into 91, and that is 2366. Let's find the product of HCF and LCM. And the product of HCF and LCM is again 2366. So by these two results, we can say that product of integer is equals to the HCF into LCM. And therefore we can say, okay, so the same way you can solve other 2 questions of questions 2. Okay, so that is for your practice. You have to solve question 2 and 3 of question 2 yourself, but here for your help I have just factorized the given integers 510 and 92. Okay, the remaining points you have to solve yourself. And the same way we have to solve the question number 3's sums. In question number 3, 3 sums are given. The first one is 12, 15 and 21. We have to find LCM and HCF with the prime factorization method. So first of all, we will write prime factors of given integers. And here are the prime factors of given integers. Now to find out HCF, we will write only common factor 3 with the lowest power. And for LCM, we will write common factor 3 as well as non-common factors 2, 5 and 7. But here we will write the highest power. Okay, therefore 3 into 2 square into 5 into 7. And the value of this production is 420. So LCM is 420. The same way you can solve other 2 sums of question number 3. Here in question number 4, HCF of 2 integers 306 and 657 is given 9. But LCM you have to find yourself. To find out, to solve this question, we'll use the result that we got a little before. And the result was LCM of integers a and b is equals to product of a and b divided with HCF of a and b. We'll put the values of the integers a and b as 306 and 657. And LCM of 306 and 657 is equals to 306 into 657 by 9. Now I will make factorization of 306 with 9. When I will cross 306 with factors of 9, we'll get 34, and product of 34 and 657 is 22,338. Okay, so up to now, whatever questions, whatever examples are remaining, that you will solve yourself. So please mind to solve the illustrations 6, 7, 8 and the questions up to question 4 that I have explained at last. Questions up to question 4 of exercise 1.2. See you in the next lecture. Bye.